Okay, so this is number one from the sample exam. We've got an ellipse on the graph here. We're supposed to find the standard form of the equation of the ellipse and give the location of its foci. Okay, so this is kind of how I work this out. The first thing I do is I start writing down kind of the standard form of an ellipse without all the stuff filled in. This is just what you always have kind of for every ellipse. Notice I've got the centers missing and then A and B missing here. So the first thing I do is I look at my graph and I find the center. I can see it's centered at 0, 0 on the origin. So that's the first thing I'm going to fill in. And you'll see that in x plus 0, that's just going to be x. That'll go away later when I simplify. But just so I'm clear to myself that I considered that. The next thing is to get these A and B down here. So I look at the ellipse and I've kind of drawn a little sketch of the graph. These are a little hard to read, but this is going to be the length of A, right? And since it's the horizontal distance, it's going to be under the X. Okay, what's A and what's B is, sometimes differs from book to book, but I always just think if it's the horizontal distance, this one's going under X. Okay, and then B is just this distance. That's supposed to be a B, not a 0, but that's length 3. Okay, so A squared is going to go here, and B squared is going to go here. So there's A squared, and then there's B squared. And then I just kind of neaten it up. X plus 0 is X, and then I square both the denominators to give me my standard form ellipse equation. Okay. So that's all I need for the equation. Now it's just left to find the foci. And this is one of those formulas you just kind of have to memorize. The nice thing is it kind of looks like the Pythagorean theorem. And in fact, for the hyperbola, it is just A squared plus B squared equals C squared, the Pythagorean theorem that you're used to. But on the ellipse, there's actually this minus here. Okay, so A squared minus B squared is going to equal C squared, or really whatever the bigger number is under the denominator minus the smaller number under the denominator is going to equal your C squared. So A squared minus B squared, that's what, 64 minus 9, which is 53. And then I just square root both sides. Now 53, you should simplify it if you can. Pretty sure that's prime, so it can't go any further. And then I just need to consider the graph here and figure out where the points are. So that C just tells me how far off of the center of the ellipse the foci are. So if I go square root of 53 in this direction, right? So this square root of 53 is like some decimal between 7 and 8, right? So if I go 7 point something in this direction, I'll get to this foci. If I go 7 point something in this direction, I'll get to this foci. And just because I'm traveling along the x-axis, the y-coordinates of both of these points are 0. And then just the x-coordinate is square root of 53, right? Now, if the center was in a different place, this might be, say, 2 plus square root of 53 and 2 minus the square root of 53. If the center was over here, let's say, at 2. But because I'm going from the center, it's just, positive square root of 53 and negative square root of 53. So I hope that it helps on that, on this problem.